Good morning, students. So today again we will be continuing with the examples on integration. Okay. So in the yesterday's class we had discussed up to example number 35. Okay. So today we will again continue with some more examples on integration. Okay. So in the last class I had already told you. Okay. Integration chapter it is consisting of at least 5 to 6 questions in your Karnataka CET. Okay, and some concepts I had told you. Okay, so from where the questions are occurring, so you need to just I will revise it once again. The first concept is integration by substitution. So most of the questions are occurring by on the method of integration of by substitution. Next, integration of special types. Okay, so you have direct formulas like integration of 1 upon x square plus a square is equal to tan in 1 upon a tan inverse x by a plus c. So such special formulas are there. So we are making use of such integrals. Okay, special types. Next, third one, by parts. So few examples we had discussed on by parts. Okay, so try to solve some examples on by parts, and then partial fraction. So one or two partial fraction because they are very lengthy. Most of the times they don't ask a question on that, but 30-40% chances are there on partial fraction also. And then the very important is properties of definite integrals. Okay, so properties of definite integrals, maximum questions are being asked on properties of definite integrals. You may get at least 2 questions in the upcoming CET exam also. Okay, and if you see the previous year's papers, last 3-4 years papers, so 2 to 3 questions are been based on the properties of definite integrals. Okay, so we'll continue with the first question here. The value of integration of e raised to x, x square tan inverse x plus tan inverse x plus 1. Okay, tan inverse x plus 1 dA upon x square plus 1 dx is equal to, okay, is equal to. So here we can see again we are making use of the integral. Okay, integral formula. So here again we are making use of the same formula which we had used in the previous example. So here we are making use of the same formula result. Okay, so integration of integration of e raised to x. Okay, integration of e raised to x, integration of e raised to x, f of x plus what, f dash of x and dx is equal to e raised to x f of x plus c. Okay, so this is the formula we are making use of. Okay, this is the formula we are making use of. So using this formula we can simplify this example. Okay, so see in this particular question, first what we are doing is, see, we are taking x square plus 1 common. Okay, so we will go through the solution. See, pay attention. So see here we are taking in the first 2 steps. Okay, in the first step what we are doing is we are taking tan inverse x common. So when we take tan inverse x common here, okay, we the remainder, the factor we get is 1 plus x square into tan inverse x plus c. Now see, 1 plus x square and 1 plus x square will cancel off. So only tan inverse x will remain. Okay, and the next term will be 1 upon 1 plus x square. So here we are splitting the denominator. ಏನು ಮಾಡಕತ್ತೀವಿ ಅಂದ್ರೆ denominator ಗೆ split ಮಾಡಕತ್ತೀವಿ ಎರಡು parts ನಲ್ಲಿ. So first term is this, and then second term upon denominator. So when we do this, we get tan inverse x plus 1 upon 1 plus x square. Okay, so now see, this will act as f of x. Okay, this is the function, and we know derivative of tan inverse x. The derivative of tan inverse x is what, 1 upon 1 plus x square. Okay, so again it is in the form of what, e raised to x f of x plus f dash of x dx. Okay, so on simplifying we get directly, so directly better make use of the formula. See, this is f of x and this is f dash of x. So directly you can write it as e raised to x tan inverse x. Okay, so this extra procedure is not required. Okay, directly you can make use of the formula and simplify it. Okay, here they have used by parts, okay, for this term, but not required. Okay, not required, directly you can do it. So by making use of the formula e raised to x, so remember this formula, I guarantee a question will be there on this every year. Okay, so either it will be, see, either this question will be asked in 1 mark for board exam. Okay, so already board exams are over, or either in CET. Okay, so very important formula. Once again, I am writing it. See, e raised to x f of x plus f dash of x dx is equal to e raised to x f of x plus c. Okay, so very important result it is. Okay, next example, question number 37. Hope these steps are clear. 36th. Okay, so next we will go to the example number 37. Okay, example number 37. So see, in this particular example, the value of integral from minus pi by 4 to pi by 4 sine raised to 103x into cos raised to 101x and dx is, okay. Dx is, okay. So here, see, this particular function, it is a mixture of even and odd function. Okay, see, even function as well as odd function. Okay, so when we multiply even and odd function, we get the product as what? Odd function. Okay, we get the product as what? Odd function. Okay, so see, sine x is a odd function. Okay, and cos x is a even function. Okay, see, this part is odd function, this part is a even function, and we multiply odd and even function, the product will be odd function. Okay, and we know integrals of odd function minus pi by 4 to pi by 4, since it is odd function, this overall function will be a odd function, and for all function always the integral will be equal to what? 0. Okay, so according to the properties of definite integrals, again the product of odd functions is equal to what? 0. So option D will be the right answer. Okay, option D will be the right answer. Okay, so see, this question has again been asked from properties of definite integrals. Okay, properties of definite integrals, the previous question was asked from parts by parts. Okay, integration by parts. Okay, so these concepts are very important, so try to solve at least minimum. Here we are discussing few examples from on your own. New swantage at least 15 to 20 examples madri in the from the other competitive books. Okay, so you can try to do some objective type examples, or even if you solve your board level examples properly once again also, it will help you to attempt these questions. Okay, next question number 38. Yes, so in the question number 38, okay, it's given that the value of e raised to 6 log x minus e raised to 5 log x divided by e raised to 4 log x minus e raised to 3 log x dx is equal to, okay, is equal to, we need to simplify this. Okay, so this one we can simplify by making use here. Actually, this example is again based on the formula. Okay, so here we are making use of the formula. Okay, so we know e raised to log f of x will be directly equal to what? F of x. Okay, or you can just consider, instead of function, if x is there, then the value, the result will be equal to what? X. Okay, so here what we are doing is, in the first step we are shifting these powers. Okay, so 6, it will be x raised to 6. Next 5, you shift it here by using the formula log of n log p. Okay, n log p will be equal to what? Log p raised to n. Okay, so I'm making use of this formula from log. We can write this in okay, this form, that is power. Okay, so this will be x to the power 3. Okay, and next step what we can do is, we can make use of this formula. Okay, e raised to log f of x is equal to what? F of x. So only this term will be the resultant, okay, or the output. So see, what do we, how we can simplify this one. Okay, so see, here we are shifting the powers first. So after shifting the powers and making use of the formula e raised to log f of x is equal to f of x. So only x raised to 6, x raised to 5, x raised to 4 and x raised to 3 terms will remain. So x raised to 6 minus x raised to 5 upon x raised to 4 minus x raised to 3 dx will remain. Okay. So now in the numerator we are taking x raised to 5 common. In the denominator we are taking x raised to 3 common. So x minus 1 will cancel off. Okay, x raised to 5 upon x raised to 3, it will be x square dx, or on simplifying we get x cube upon 3 plus c will be the answer. Okay, x cube upon 3 plus c will be the final answer. Okay, so you can see x cube upon 3. So option B. Okay, so integral constant is not written, only the value is written. Okay, x cube upon 3. Okay, hope the solution is clear. Okay, next example number 39. Okay, so see, again this is based on properties. The previous one was based on simple basic formulas. Okay, only by making use of simplification we solved the previous example. Now see, in this particular example, okay, again we are making use of the properties. So see, 0 to pi by 2 sine 1000 x dx divided by sine 1000 x sine x raised to 1000 plus cos x raised to 1000 is equal to, okay, is equal to. Okay, so see, when such type of questions are occurring, okay, such type of questions are occurring, we are making use of the property 0 to a. Okay, 0 to a f of x dx. Okay, 0 to a, see, 0 to a 0 to a f of x dx can be written as 0 to a f of a minus x dx. Okay, so this is the property we are making use of. Okay, and see here the power a power is what, pi by 2. Okay, so by making use of this, see, when we replace this x, okay, we need to replace x with pi by 2 minus x. Here we need to replace x with pi by 2 minus x. Okay, so sine of pi by 2 minus theta is what? Cos theta. Similarly, sine of pi by 2 minus theta will be cos theta, and cos of pi by 2 minus theta will be sine theta. Okay, so by making use of this trigonometric identity, trigonometric result, see, pi by 2 minus theta is equal to what? Cos theta, and cos of pi by 2 minus theta is equal to what? Sine theta. Okay, we can rewrite this. Okay, so first what we will do, we will consider this as integral I, and then again we will make use of this property, second property. See, pay attention how we can simplify this one. Okay, so first we are considering it as I. Okay, first we are considering the given integral as what? I. So after, okay, consider it as I, and then make use of the property 0 to a f of x dx is equal to 0 to a f of a minus x. Okay, so when we make use of this property, the limits will remain as it is. 0 to pi by 2 will remain as it is. In place of x, we need to replace it by what? Pi by 2 minus x. And then similarly, sine of again pi by 2 minus x, and cos of pi by 2 minus x. Okay, so when we simplify it further, see, sine of pi by 2 minus x, using this result, it will be cos theta. Okay, and then cos of pi by 2 minus x, it will be equal to sine theta. Okay, it will be equal to sine theta. Yes, see, sine of pi by 2 minus x. Okay, this result. So using this result, we will get the equation 2. So first integral we have considered. Okay, add 1 and 2. See, I plus I, it will be equal to what? 2i. I plus I, it will be equal to 2i. Okay, now see, when we add a cos x plus our cos x raised to 1000 and sin x raised to 1000 we get, and when we add this, the numerator and denominator will be same, so it will cancel off. So here we will get 1, and integral of 1, we know it is x. Substitute the limits 0 to pi by 2, it will be pi by 2. Now shift this 2 on the RHS, so the final answer will be equal to pi by 4. Okay, the final answer will be equal to pi by 4. Okay, so see, based on the properties, better try to solve the questions from the board textbook. See, from your textbook, I think exercise 7.11. Okay, 7.11 is based on the properties. Okay, it is based on the properties. Okay, last exercise, last and previous to this, that is 7.10. Okay, both the exercise you try to solve once again, and it will those questions from the solved examples before the exercise and exercise examples, either one or two questions you may get from there. Okay, at least one question also if you get, it will be very good. Okay, so based on the properties, solve the exercise there. So at least out of 6 questions on integrals, 2 questions you can catch hold from there. Next question number 40. Yes. Okay, so see again the value of okay, the value of integral over 2 to 8 root of 10 minus x divided by root x plus root of 10 minus x dx is. Okay, so we need to calculate this value. Okay, again here we are making use of the properties. Okay, but first we are simplifying this. Okay, we are simplifying this, and then okay. So see here, what we are doing is, okay, now what we are doing is again the similar property only we are using. Just we are replacing this x with, uh, okay, with same term, that is 10 minus x. Okay, so whatever the previous case we had used, a minus x we had used. Okay, here we are doing a plus b. See again there is a property. The other property is, okay, see, pay attention here. Okay, we are making use of the property. See, a to b, f of x dx is equal to, okay, a to b. Okay, so the property is a to b f of a plus b minus x dx. Okay, so here we are making use of the property a to b f of x dx is equal to a to b f of a plus b minus x dx. Okay, so see, where there is x, we are replacing it by what? A plus b minus x. Okay, so see here in place of a it is 8 2, and in place of b it is 8. So 8 plus 2 it will be 10. Okay, so 10 minus x. So where there is x, we are replacing it by 10 minus x. So this term we are replacing it by 10 minus x, 10 minus x, and again 10 minus x. Okay, and this integral we are considering it as I. Okay, so the same result. Okay, so the previous example what we have done, we had converted that equation 1 into equation 2, added those, and then simplified. The same procedure we are following here. Okay, so see, pay attention. The same procedure we are now following here. If any step you are not understanding, you can ask in the chat box. Okay, you can put the message in the chat box. We will discuss. Okay, most of you are sending the answers. No problem. Okay, so if you are getting the answers, you can send the answers. Okay, so see, question number 40. So we can solve it. See, I is equal to 2 to 8 root 10 minus x upon root x plus root 10 minus x. So in place of x, you replace it by 10 minus x. So we get it as 10 minus 10 plus x. Similarly, in the denominator, we get in place of x, we can write 10 minus x. Again, root of 10 minus, in again place of x, we can write it as 10 plus x. Okay. So on simplifying, see, the numerator will be just root x, and in denominator the 10 minus 10 will cancel, it will be a root x. So when we add, you can see the numerator and denominator will be same. Okay, the numerator part and denominator will be same, so again it will cancel off. Okay, so the integral of 1 will be equal to x. Substituting the limits, we get 8 minus 2. 8 minus 2 is 6, and then divide, shift this 2 on the RHS, so we get 6 upon 2. 6 upon 2, it will be equal to what? I. Okay, it will be equal to I. So the same property we have made use here. Okay, we have made use of the same property and simplified. Okay, so next example, example number 41. Yes, okay. This question is also from your NCERT book only. Okay, and this question also is repeated twice in the Karnataka CET exam. So here they have asked us to calculate integration of minus 5 to 5 mod of x plus 2 dx. Okay, mod of x plus 2 dx. Okay, so here first what we have to do is we have to split this function, okay, by making use of the definition of mod. Okay, so by making use of the definition of mod, ಏನ್ ಮಾಡಬೇಕು ಇದಕ್ಕೆ split ಮಾಡ್ಕೋಬೇಕು. Okay, so here we have to apply the definition of mod function. Okay, so what is the definition of mod function? It states, okay, we know mod x is equal to x and minus x. Both we are getting, yes or no? The positive value also we are getting, as well as the negative value. So see, mod x is equal to, see here, pay attention. So once you understand the property, so later even if there is the change in the numerical value here, you can easily attempt the question. So see, mod x is equal to x, it is equal to x, and also it is equal to what? Minus x. So it will be equal to x when it is greater than equal to 0, and it will be minus x. Mod value will be equal to minus x when x is less than 0. Yes, when x is less than 0, it will be minus x. Okay, so now see here, what we have to do is, see, instead of x, what is given here? Mod of x plus 2 is given. Okay, so see this mod of x plus 2, how it will behave. Okay, so see, we need to find, see, this x plus 2 will be 0 when x is equal to what? Minus 2. Okay, when x is equal to minus 2, meaning is at minus 2 the value will change. Okay, at minus 2 the value will change. So see, this interval we can split it as minus 5 to 5. So in this part of the interval, that is when it is less than minus 2, when x is less than minus 2, it will act as negative. And when it is greater than, okay, when it is greater than minus 2, it will act as what? Positive. So here we will get the negative value, and here we will get the positive value. Okay, so we can simplify this. Okay, so we can, I will just write the step, and then we will see the simplification. See, minus 5 2, first we are writing minus 2, and then here we are making use of minus x plus 2 dx. Okay, and then see, or if you want, you can write mod sign, and next step you can substitute and say plus minus 2 to 5, and this will be plus x plus 2 dx. Okay, so this is how we need to split. Okay, now suppose instead of x plus 2, it would be x plus 5. Okay, or x plus 10. Okay, so see, if it would be x plus 3, okay, it would be x plus 3, then x is equal to minus 3, this whole function will be equal to what? 0. Okay, so the interval will split between what? Minus 5 to minus 3, and then minus 3 to 5. Okay, so, and this is how you can split the function, and once you split the function, the rest procedure is very easy. Okay, so see, pay attention how we can simplify it. So again, the example is from 7.11 of your NCERT book, the same example they have asked as it is. Okay, so next, see what they have done. So they have used a minus sign for integral from what? Minus 5 to, for minus 5 to what? Minus 5 to minus 2. Okay, x plus 2 dx plus minus 2 to 5 x plus 2 dx. Okay, so when we integrate, x integral will be x square by 2, x2 integral will be 2x under the limits what? Minus 5 to minus 2. Similarly, again simplified, x square by 2 plus 2x from the under the limits minus 2 to 5. Okay, substitute minus 2 one time, and then minus 5, subtract the result. Okay, so you get 9 by 2 plus 49 by 2, it is 58 by 2, and on simplifying, the final answer we get it as, okay, the final answer we get it as 29. Okay, we get it as 29. So 29 will be the final answer, that is option B. Okay, Okay, so next example number 42. So say cos 2x minus cos 2 theta upon cos x minus cos theta and dx is equal to, okay, is equal to. So we can simplify see this result. Okay, so here we are making use of again formula, okay, substitution method. So we are substituting the terms by making use of the formula, okay, and then simplifying it further. Okay, so see here cos 2x minus what, cos 2 theta divided by cos x minus cos theta dx is equal to, okay, so here cos so see here cos 2x, we can simplify it by making use of the identity cos 2 theta. Cos 2x, we know the formula, it is equal to 2 cos square x minus 1. Similarly, cos 2 theta also we can make use of the same identity 2 cos square theta minus 1. Okay, so by making use of the property and substituting, see how we can simplify it. Okay. Yes. Okay. So see, I is equal to, we are considering cos 2x minus cos 2 theta upon cos x minus cos theta. So see, cos 2x can be written as 2 cos square x minus 1 minus 2 cos square theta minus 1 divided by cos x minus cos theta. Okay. So see, 2 you can take common, and cos square x minus cos square theta you can make use of the identity a square minus b square. So minus the factor which is consisting of the negative sign will cancel up with the denominator, so only the positive term will remain, that is cos x plus was cot theta dx. Okay, and see theta only we need to integrate now. Okay, so this theta will act as a constant. Okay, the theta term will act as a constant. Okay, it will act as a constant, so along with constant we have what, 1. So see cos x derivative will be minus, it will be sin x. Okay, and then for 1 the integral will be x cos theta. Okay, so most of the students see, since it is integrated with respect to what, okay, the variable is dx. Okay, we are integrating with dx, not with theta, so only we are treating it as a constant. Okay, this cos theta we are treating it as a number. Okay, and integral of 1 will be what, x. Okay, so the final answer will be 2 into sin x plus x cos theta plus c, and that is the option A will be the right answer. Okay, option A will be the right answer. Okay, next example, question number 43. Okay, this question number 43, I am giving you 2 minutes time. You can try to simplify it on your own. It's a easy question. Okay, try it. It is based on the same property what we discussed. Integration of e raised to x f of x plus f dash of x is equal to e raised to f of x plus c. Okay, so same property you have to apply. Try it. I will give you 2 minutes time. Okay, Madan has answered it as option A. Okay, rest of the students also try it. Another 1 minute. See which option you will be getting. Yes, no, answer that previous example. Okay, see, try it. Try it. Tell me the answer. 42, yes. Siddhanand Gowda. Siddhanand Gowda has answered A. See, rest of you try it. Same property. And then we will discuss the solution. Okay, so only two of you have answered. Okay, two of you have answered. Okay. So see, pay attention. The next part, what we can do here. So in the solution we have, we'll discuss the solution for this. So you can check your answers. Okay. So see here what we are getting. See again we are making use of the same property e raised to f of x plus f dash of x dx is equal to e raised to f of x plus c. So for that okay, to make use of that we are simplifying this result. Okay, see the numerator we are splitting it as x plus 4 minus 1. Okay, so, and when we split the denominator we get x plus 4 upon x plus 4 whole square. It will be 1 upon x plus 4 minus okay 1 upon x plus 4 whole square e raised to x and dx, which is equal to e raised to x upon what x plus 4 plus c. Okay, e raised to x upon x plus 4 plus c. Okay, so see here we can see simplified. So see e raised to x f of x plus what f dash of x dx is equal to e raised to f of x plus c. So using the same property we get the answer as what e raised to x upon x plus 4 plus c. So the option A will be the right answer. Okay. So again, this is the extended part of what the formula is. Uh, by making use of by parts, we are making use of we are obtaining this formula. Okay. So the same for result we have used. Okay. So you can see in the previous 2-3 years the same question has been repeated. Okay. Next example. Example number 44. Okay, example number 44. So you can mark it as an important question. Most of the time they ask this question. Okay, so see in the denominator we have 1 upon a square sine square x plus b square cos square x dx is equal to okay is equal to. So here what we are doing is we are dividing. Okay, we are dividing by the first term of the denominator. Okay, sorry, we are dividing it by the second term of the denominator. Okay, so this, so we are dividing the complete see here, pay attention. So here what we are doing is we are dividing the expression by b square cos square x. So when we do that, okay, when we do that we can see we can see that. So just by cos square x you divide, so you get see a square sine square x upon cos square x. So sine square x upon cos square x, it will be tan square x. Now cos square x will cancel, it will be just b square, and in the numerator the term which we have divided, its reciprocal will be what secant square x dx. Okay, now see we are replacing making use of the substitution method. Tan x is equal to t. So when tan x is equal to t, the derivative of tan x is secant square x dx is equal to dt. On simplifying, we get I is equal to 0 to infinity dt divided by a square t square plus b square. We can take out a square, so it will be in the uh, type t square plus b square upon a square. So on simplifying it further, see 1 upon a square is constant. Okay, and this is of the type what okay x square plus a square, whose integral is 1 upon a tan inverse x by a. So by making use of the result we get a by b tan inverse at upon b 0 to infinity, and on substituting the limit we get pi upon 2ab. Okay, so pi upon 2ab will be the final answer. Okay, will be the final answer. Next, question number 45. Okay, so question number 45 I am giving it for homework. Okay, just we are discussing. So see, this is again a direct question. So here we need to split this integral root of x square plus what 2x plus 5 as sum of a perfect square plus some term. Okay, sum of a perfect square plus some term. So see here what they have done is they have split it as x plus 1 whole square. Okay, x plus 1 whole square plus okay x plus 1 whole square. We can do it as x plus 1 whole square plus 2 square. Okay, plus 2 square. So here okay, so using this what we can do, we can make use of the property root of x square plus a square, which is nothing but x by 2 root of x square plus a square dx plus log of a square by 2 log of x plus root of x square plus a square plus c. So by making use of the property and substituting, we will get the option B as the right answer. Okay, option B as the right answer. Okay, what happened, Madan Nayak? What happened? Hello, any doubt, Madan? Is there any doubt? Hello, no doubt. If any doubt, you can put it in the chat box. Okay, no, sir. Okay. So next we will go to question number 40. Okay, 46. Okay, question number 46. See, pay attention. So the question number 46 is okay, minus pi by 2 to pi by 2 dx upon e raised to sin x plus 1. Okay, e raised to sin x plus 1. So again, this particular question we can make use of our properties. Okay, so whatever the definite integral properties are there, okay, by making use of that, we can simplify it. Okay, we can simplify it. So first what we are doing here is, see, the first step, we are making use of, first we are considering the given integral as I. So I is equal to dx upon e raised to sin x plus 1, and then we are, okay, using, see, I is equal to minus pi by 2 to pi by 2 dx upon e raised to sin x plus 1. Okay, so we are making use of f of minus x, and on simplifying, we get, okay, e raised to, see, when we simplify this, we get e raised to sin x upon 1 plus e raised to sin x. So by adding equation 1 and 2, again the numerator and denominator part are same, so it will cancel off. The answer will be equal to what? 1. Okay, it will be equal to 1, and integration of 1 will be x. On simplifying, we get minus pi by 2, pi by 2 minus pi by 2, so it will be equal to pi, and 2i will be equal to pi, or I will be equal to pi by 2. So pi by 2 will be the final answer. Okay, so in such type of questions, okay, if pi by 2 we are okay, most of the time the answer will be either pi by 2, pi by 4, or pi. Okay, so such values only we get. Okay, so without simplifying, you can't predict the answer directly. Okay, so you need to simplify. Next, so this example is similar to the example what we had discussed with respect to sine. Okay, so see, for sine and cos we had discussed. See, whenever, see, pay attention, whenever such terms are occurring. Okay, terms like, see, pay attention. So in the example, if these ratios are occurring, okay, if the question is mixture of sine and cos, tan and cot, sec and what, cosec. Okay, so these are all what, co-ratios. So whenever co-ratios are occurring, okay, whenever co-ratios are occurring, okay, and the integral is from what, 0 to pi, okay, 0 to pi by 2, okay, then directly you can get the answer as what, pi by 4. Okay, because we have made use of the, we need to make use of the property, and the same result we get, okay, for such type of questions, that is pi by 4. But here the integral must be away from what, 0 to pi by 2, and the question must be mixture of this. So directly you can remember the answer will be what, pi by 4. Okay, the answer will be pi by 4. Next, question number 48. Okay, question number 48. Okay, question number 48, 47 at least we have done. Okay, next, question number 48. Okay, so here it's a 0.2. Okay, integral from 0.2 to 3.5 step x dx. Okay, so here we are making use of the greatest integer function. Okay, greatest integer function. So for greatest integer function, we know, okay, it will take, okay, it will take the value less than or equal to the greatest integer. Okay, so here we need to split it in the intervals. Okay, we need to split it in terms of intervals. Okay, so what are the intervals we will get? Okay, So here we can write, see, the integral is from 0.2 to 3.5. Okay, so 0 to 4, we can make use of the intervals from what? 0 to 4. So when we make use of the intervals from 0 to 4, what do we get? See, okay, what do we get actually? See, what do we get? Pay attention here. Yes. So see, 0.2 to 3.5. Okay, what are the values we are getting? See, pay attention here. 48. So see, we are splitting this. So we are starting from 0.2 to 1, next 1 to 2, 2 to 3, and then 3 to 3.5. Okay, 3 to 3.5. So in this interval, we know the value of the step function is equal to 0. Okay, when it is in between 0.2 to 1. Similarly, for 1 to 2. So see here, we are making use of this properties. Okay, of okay, so see, when it is, so when x is between, so see, when x is between 0 to 1, okay, 0 to 1, see, pay attention. So when x is between 0 to 1, see this step x, okay, step x will be equal to 0. Next, similarly, when 1 x less than 2, step x will be equal to what? 1. Similarly, 2x and then what? 3. Okay, the step x will be equal to 2. And similarly for 3x, so here we have only till 3.5. So the step x will be equal to what? 3. Okay, so these are the values. Now on simplifying, see, now what do we get? So 0, you will be getting 0, 1 integral will be x, 2 integral will be 2x, and 3 integral will be 3x. So on substituting, we get 2 minus 1, it will be 1. Similarly, here 3 minus 2, it will be 1, and 3 into zero point 0.5. So on adding, you will get the result as what? 4.5. Okay, 4.5 will be the answer. Okay, 4.5 will be the answer. Okay, next example, example 49. Okay, so integral of 1 upon 1 plus e raised to x dx is equal to, okay. So here what we have to do is, okay, what we have to do is, again, okay, again what we have to do is, okay, first we are replacing x with what? A minus x. So if you replace x with minus x, you will get it in the form of I is equal to e raised to minus x upon e raised to minus x plus 1, and then replace this denominator with t. So when we make use e raised to minus x plus 1, when we substitute it as t, we get it in the form of 1 upon t and 1 upon t, okay, minus 1 upon t. So the answer will be minus log e raised to minus x plus 1 plus c, or on simplifying, we get log of e raised to x upon 1 plus e raised to x plus C. That is the option C will be the right answer. Next, so this is direct. You all can do it. Okay. So again, we have 1 upon 3 minus 6x minus 4x square. So it will be in the form of a square minus x square form. Okay, a square minus x square. And you will get the integral in terms of what? Sine inverse. So again, you need to write it in form of what? Perfect square plus some term. Okay. So solve it for homework. Option C will be the right answer. Okay. So question number 51. See again, in the question number 51 is based on the same property, e raised to x f of x plus f dash of x. So same property you all use. Simplify the question number 51. The answer will be option A. Okay. Next, 52. Okay, question number 52. Important question also. Okay, important question. So here again we are making use of the mod function, integral from what? Minus 2 to 2. Okay, minus 2 to 2. So you all try this. The solution is here. Once again, you all try to do at home. Next question, see, was 0 to 1 dx upon e raised to x plus e raised to minus x. Okay, so this one again we can make use of the substitution, and simplify. Okay, so first what you have to do is you have to take e raised to x common. Okay, take e raised to x common. So you will get it in the form of 1 plus e raised to 2x, e raised to x. Then make use of the substitution. 1 plus e raised to 2x. Okay, so e raised to x you will substitute it as t. So it will be e raised to x dx is equal to dt, or 1 upon t square. So this will be nothing but tan inverse t e upon 1, or tan inverse e minus pi by 4 will be the final answer. Okay, will be the final answer. Okay, so we will conclude our class here. So I will stop here. Remaining part, so see, up to question number 60, it's been given in this PDF. Okay, you can take the PDF and solve it. Okay, so next, in the next class we will discuss the next part of integration, that is application of integration. Okay, so you may get 6 questions from this, and 1 question you may get from application of integrals. Okay, so in the next class we will discuss the examples on application of integrals. Okay, so we will stop here. We'll meet tomorrow. We'll meet again, one more session we have, we will meet. Okay, till then, take care. Bye.